I mean, the stuff that aerospace and defense is typically trying to protect is, I won't always say in today's world, it may not be existential, but it's quite important, and there's billions of dollars behind the investments that have been done to create some of that stuff that you're trying to protect. And the adversaries are quite sophisticated as opposed to the average guy trying to break into, steal bitcoins. So I would argue that it's more about the stakes and the adversary that makes it a little more difficult. And because the supply chain and the development and the innovation chain is so distributed, it's not all held in one party. Most of the significant breaches were always good housekeeping failures. Somebody putting a thumb drive where they're not supposed to, somebody having a password that they were sharing. You tailor your leadership to the needs of the team, and you motivate people with what's going to motivate them, which requires you to change, not them. Because you're going to have to figure out what motivates people, how to get them there. That's your job.
Today, I'm sitting down with Brad Berkson, CEO of MileSpace, an aerospace and defense innovator who has had quite the journey. Brad has had an immensely decorated career. He served as a senior official in both the Bush and Obama administrations, held executive roles in the private sector, and is now leading the charge in space technology. Welcome to the Be Fearless podcast, Brad.
Thank you. Glad to be here.
So let's talk a little bit about your history so the viewers get to know you a little bit better. With such a fascinating career history, could you walk us through it a little bit?
Okay, sure. So I started my career with Exxon, working in Prudhoe Bay on the North Slope of Alaska, which was pretty exciting. Living in California and surfing every day, I didn't have to deal with the tundra very often, but when I did, it was a great job. I then went to the Harvard Business School and got an MBA. And then I joined McKinsey and Company and eventually became a partner at McKinsey. And in 2000, I got the idea for essentially what's now called the Internet of Things. And I left McKinsey on March 1st of 2000 at the peak of the internet bubble and raised a couple $1 million for this company, and then watched the internet bubble burst and tried to figure out how to survive through ever-changing requirements for a startup. I actually sold the company and we moved to Northern Virginia, and I became president of a company that had a similar interest in technology, but given the world had changed so fundamentally, we essentially went back to their core business, and I was able to help them recruit a pretty good management team. That company, actually, when we merged with them, was worth about $70 million, mostly them, and eventually sold several years later for $1.5 billion. So they did pretty well, and I was lucky enough to be at the right place at the right time. But after 9/11, I'm in Northern Virginia and looking for something to do next. And through a miraculous connection to the Department of Defense, I ended up getting appointed to a senior position in the Bush administration, working for Secretary Rumsfeld. I started as acting Deputy Undersecretary of Defense for Logistics and Material Readiness. So this is the guy who runs all the supply chain stuff for the department. That was like 1 million people and $200 billion. So lots of operational stuff. And then Secretary Rumsfeld asked me to be the director of what was then called Program Analysis and Evaluation. This is the guy or gal who operates the Future Year Defense Program. So we had at the time $3 trillion, it's probably $6 trillion of budget that we were looking at for the long term. And I had a team of about 500 people, from economists to doctors to physicists, trying to figure out the fact base for why you would do how much was enough and where should you spend the money. The department, and I was an independent advisor to the secretary. And I served Rumsfeld and Gates. And then Secretary Gates was the first defense secretary I ever asked to extend into an opposite party's administration. So he remained as Secretary of Defense under President Obama. And he asked me to stay and help out for a few months, and I did. And then I left the Pentagon, and I joined a number of boards, including Boeing Defense and Space. I was also the chairman of the National Defense Business Institute, chairman of Civil Logistics Governments Businesses, number of jobs like that. In 2014, I joined and then became the CEO a company called N12. N12 was making carbon fiber or carbon nanotubes for carbon fiber applications. And I did that for a while. That wasn't fortunately as successful as my first startup had been. So we ended up having to eventually shut that thing down. And then in 2020 or 2021, I joined a space company here in Florida, and then eventually became the president of Miles Space. So I haven't figured out what I'm going to do when I grow up yet. I'm still looking at various things. The service in the Pentagon was clearly the best job I think anybody could ever have. It didn't pay well, but the toys were great. So,
I was talking to someone else late last week, I think, and we were talking about the work that we did in the military. Like, we're working with the military, and having that mission focus, supporting the war fighter, supporting the country. I think it makes you feel good about what you're doing every day. And so it's hard to build that same kind of culture and other enterprises.
Just because it just doesn't matter. That's why what you do at the Pentagon really matters.
Absolutely. I mean, you're doing something that is bigger than yourself, right? It's totally different than selling consumer goods to people and other kinds of things, right? So, but it was, I feel the same way about my time working with the military. Even though I was never in the military, I was always a contractor of the military or civilian style person, right? Yeah. I definitely felt like what I did mattered. I could see how it mattered every single day to the warfighter and everything else. So it's a different kind of world than commercial.
Absolutely. Yeah, everybody should serve their country at some point because it really teaches a lot.
Yeah, I think it also played down a lot of the conspiracy theories people have.
Yeah, I tell people I was in places that don't exist and saw things that don't exist and never saw any aliens. So
right, exactly. It's like trying to keep all these people to keep a secret. That's actually kind of hard. So, but so you've had a lot of your career journeys. Very varied. It's a very interesting career journey. Looking back at it, you've had some good exits. I mean, I think those are good, but was that a risky career move or did you have some other risky career?
Being a partner in McKinsey and Company and making 7 figures and then walking away to start a startup, that's kind of risky. Now, at the time, there was billionaires being made right and left. One of my section mates one of my good friends from grad school had been a billionaire recently, and he was for a week or two. So that was after the fact, leaving a high-paying job and then going to the Defense Department mid-career. From a financial standpoint, was a pretty risky thing. My pay got cut by 5x, 80% pay cut to go serve the Pentagon. So that seemed risky at the time. And then doing another startup and things. But I found it just, for me, that's what I like to do. I'm a novelty junkie. I like new problems. I tell people, if you want me to help. If we're going to Mars, you want me on the team. If you're going to the market, you don't want me on the team. There's lots of people that can get you to the market, but not a lot of people can get you to Mars. So that's the kinds of challenges and things I really thrive in.
That's good. Yeah, definitely would be risky going from a partner to a startup, especially like right before the .com bust, right? That was such a weird time.
Yeah.
I remember that time. Everyone was hiring, and it seemed like all valuations were made on by how many people you had on your staff. It had nothing to do with like business at all.
Right.
So, running a business that was actually making money, I don't think that was a requirement at that time, which is probably why the bust happened, right?
Yeah, exactly. Well, again, the NASDAQ was at 5,000 when I did that. It didn't get back to 5,000 until about 4 years ago.
Right. And then you even said that, as you were kind of going through that startup journey, what people were expecting you to have for your startup changed, right?
Every week, every month, it was different. We would deliver something and then, sorry, now it's there. It's basically, they were changing the goalpost. The coal line kept moving 20 yards every 2 months.
Exactly. It was a weird time. Well, tell us a bit about Miles Space and what motivated you to work there.
Well, Miles is very interesting. I got a founder. I'm working with a founder who's a genius. Didn't actually ever work in aerospace. But this is a gentleman who at fifth grade built a particle accelerator for his science fair project. These kind of people. I grew up in New Mexico and had to deal with these people in science fairs. They were all from Los Alamos. People are doing the volcano, and these guys are doing, small level nuclear fission experiments. This is one of these guys. So instead of his midlife crisis buying a Corvette or something, he went back and started looking at some particle physics. And the area he was interested in was electric propulsion. This is the propulsion that moves satellites around once they're into orbit. A little more efficient. Doesn't have a lot of thrust, but given that you don't have any friction, you can use smaller thrust things with more time and then get things going. And so he went and looked around and found out that everything that he had thought of had already been patented. So he had been a software engineer, and he's pulled out 10 years ago, he pulled out some AI tools, really first generation kind of stuff. And he built a particle level physics model, basic physics, Coulomb level, and a generative AI system to kind of optimize that and set it working for 2 years. And it figured out a new way to do electric propulsion, brand new way that was literally order of magnitude more higher performing. And when I met him, we were at a conference in Washington, and I was working with a partner company at the time. And he was telling me about this device, and he was talking to people, and he would tell them, it performs about 10% better than others, was what was in the literature. But then when he would talk to these people, he said, well, the performance is actually like a lot better than that. And I would ask him, well, why is it a lot better if it's only 10%? He said, well, nobody believes me. I don't have, the bottom line was he didn't have any aerospace credentials. And so nobody believed the performance he was getting, and he'd get thrown out of the office because this quote would violate physics, et cetera. And I said, well, I can probably help you here because while nobody will believe my technical capability, they do believe my credibility. And, I can call up a defense prime and talk to the CEO or senior people there and get pretty quickly to whoever's important, and we can probably get you a little better of a showing. Well, as it turned out, this thing actually did work. We've actually launched 3 into orbit. It's like inventing a jet engine, and everybody's flying propellers and says jets will never work. I mean, this is literally the level we're at. And in the meantime, he actually got this placed on Artemis through a competition that NASA was sponsoring. And he got it sent on Artemis to about 10 million miles from Earth, this thruster and a small satellite about the size of a toaster. And the other problem he had is if he was talking to a toaster 10 million miles away, that's not easy to do because he only had a 3-meter dish in Dubai on Thursday afternoons that he had somebody give him for use. And so he also went back to the AI toolkit and developed ways to do very, very minute signal enhancement to take really, really fine signals and fix them up. So at this point, the company has a thruster that, like I said, has 3 in space. I've tested one of them, and it's performed, as we said, really outstanding. And then we're building and have tested this signal enhancement software. We're doing it for people like the Missile Defense Agency and others, and it has a bunch of other applications as well. So, I left the Pentagon. I was commiserating with Gordon England, who was the deputy secretary, and he said, Brad, we're never going to have jobs like this again. This is the greatest job. And I said, Gordon, you're pretty old, but I might have something for all of you.
Right.
And so the nanotechnology was pretty cool, and this is, very cool. It's nothing to compare with Pentagon. I agree with that, but still working on cool toys is definitely fun.
Yeah, but the applications for C4 ISR kind of applications are awesome. I mean, there's lots of good applications for this kind of technology.
Right. Yeah, we have a lot in the signal enhancement world. We have 4 or 5 different applications. The first is this minute signal detection to enhance the gain of a communications link. So we can improve the gain by about 10 decibels. And that didn't mean anything to me before, but that's like doubling the capacity of a link. So that's a lot. Secondly, we can take reflections of ambient radio energy in the atmosphere coming off of cell towers, Wi-Fi, radio, TV, and we can get those hitting flying objects. And like a passive sonar, we can detect the direction and bearing of a flying object without ever painting it with a radar. So it's a passive radar capability, and created again with this minute signal detection that we've done. Another is alternative position navigation and timing. we can see the radio centers of celestial objects and then deduce by the position of those celestial objects where you are in space-time, because there's unique solutions to where you are in space-time when Jupiter's here and the moon is here and the sun is here and Pulsar 342 is here and Starlink 867 is here. You can basically figure out, okay, well, that means that I must be in this place. So you don't have to use the GPS satellite. And then one that might be interesting to this audience, we can also do what's now known as radio frequency fingerprinting. So because we can get these really minute signals, we can tell the slight variations in manufacturing of the capacitors and the microprocessors in an individual electronic device that's transmitting. And we can uniquely identify that particular transmitter. So even if we had 1,000 spoofed iPhones with identical IMEDs and or IMDAs or whatever they're called, and everything was identical, we could still tell the difference in the transmission and be able to uniquely identify those sources.
Just because of attenuation and stuff like that? Or is it just because of attenuation and how they're...
Just the minute signal changes, the minute signal that, even though it's putting out the same 0 and 1, so to speak,
right.
This is RF energy, so it comes across analog. It's not purely 0 and 1. It's got hair on it. And so by the hair that's basically ignored by the rest of the system, we can say, well, that's your hair, those are your whiskers, and those are your glasses, and that's thing, because nobody else, every capacitor doesn't react exactly when you power it up. Every microprocessor has a slight variation in how it's doing. Again, and this is tens and like 10, 20, 30 decibels below the noise floor of specificity that we're able to get to. So again, you wouldn't see it in anything else, but at the level we're looking at it, you can do it. So it's a really nice anti-spooking of GPS. So I can tell you specifically that's, the GPS transponder on satellite 4, or it's not, or somebody is trying to get into your facility through an unauthorized mobile device. I can say that is not, your mobile device that's authorized to come into this. And I can you decide what you want to do. You can shut it down, or you can receive it, try and figure out what it's trying to do to you, or, what have you.
I can think of so many applications for that on the security front, meaning like just, one of the things that we often have problems with is, making sure that the user is who the user says they are, authentication kind of problems, right?
Right.
And, one of the things we use is MFA, just to clarify in my head. And so maybe the viewers can understand and clarify for me too, because I think I know what you're saying, but I want to make sure. I think people don't realize that all of the noise that, again, even though we're transmitting over, we're on a phone and it's a digital device, going from a phone to the tower is not digital. It's a waveform that's going over there.
Right.
When we have it,
it's analog.
Yeah, it's analog. And it's a continuous stream of information that's going over. Right. What happens is we have protocols that take that and they make it into packets. Those packets are then reassembled, assembled into TCP/IP or whatever protocol that we're going to be transmitting communications through. But we have equipment that's on both sides, so that the phone that you're using and then a tower that's cleaning up all that mess, right? I will say mess.
Yeah.
To make it do it. What you're saying
to the communication. So it just
it's totally ignored. But what you're saying is that it's that phone. It's not another phone, just because of how it's signaling back to wherever your sensor is, whether that sensor is on a tower or next to
whatever receiver you're having. Yeah, exactly.
Right. I mean, and then I think from a security perspective, that's incredible, because that is one of the harder things that we try to do is, how do we authenticate a user and know that that user is who they say they are, meaning that device is the trusted device that we're expecting, and on your side from a, satellite and that kind of stuff, is that, are we getting signal from that satellite, the GPS responder on the satellite, and not being spoofed by an adversary's satellite that's putting in noise? And this gets into conversations about integrity and non-repudiation. We can trust this message, this information coming from this location because we know it's this device.
Exactly.
Right?
Exactly.
Yeah. Incredible. I mean, I'm definitely going to want to go learn more about it because I mean, I think that, in my head, I keep thinking the problem is scale. I'm thinking about my time working at telco, right? Mobile network operator, and just getting equipment onto buildings so that we can make the radio work. And then, having, if it was a software solution and we could use the same equipment, then it would be easy to do this so that we could do better security on it for account takeover, those kinds of use cases. But then it's the scale of it. Like, how do you get a physical thing into places that you need to be? But there's probably lots of different solutions for that. I mean, I definitely want to learn more about it.
So what we've been, the use cases we've been thinking about, first one was the GPS anti-spoofing. So making sure that GPS is coming from a known GPS transmitter. And then when we put a new GNSS into space, that we qualify those transmitters and then we can have those. So there's one which is kind of the universal, everybody wants to know that that's the right place. So that's kind of a more published. And then there's my ones, right? I don't necessarily want to publish the things that should be entering my network, but I'd like to know who they are and make sure that they are, legitimate. And we end up, it was funny because we said, well, how would we do this for GPS? And we need a little space on the GPS receiver. And right now it's a little circuit microprocessor. I can't remember what they're called. Circuit on a board or board on a circuit or whatever it's called.
System on a chip.
System on chip. There you go. And there's exactly one bit assigned in the space that we need to do our analysis. So we only need 8, but the 8 ain't there. So it's one of these things. We've had the same thing with our signal enhancement. Our signal enhancement can go on any radio receiver, but most radio receivers, the step we need to get involved in is this understanding the hair, as we were talking about.
Yeah.
Hair immediately gets ignored. So you have to get into a place that there's really no room right now and do a little bit of work there. It's not a lot. It's not a lot of requirements, but you have to do something there. And we've had pushback from the radio folks, the modem folks that don't want us, messing with their knickers. And okay, that's good. So we ended up, in this case, we've made an appliance. It's called the Boost Box, and we just created a little black box that sits between the antenna and the radio, and nobody has to change anything. And it's not as elegant because it introduces some more noise. We have to go down from analog to digital, do our conversion, and go back digital to analog. And then it's going to go right into the radio, and the radio is going to go analog back to digital. So we introduce some noise. But from adoption and getting human behavior to work, it's a much better solution. This would be the case, I think, as well for the what we call signal print. And just on that, there's 2 historic carry capabilities of that. One has been called specific emitter identification, and this typically is in the black world. And so I don't have access to the black world anymore. So we may have something that's already exists at our friends in Fort Meade that they can do such like this. We may not, but we don't know. And then the other one is our IoT buddies are very interested in this because they want to make sure before you shut down the nuclear reactor from somebody's house, that house is actually the right house authorized to shut down the nuclear.
Yeah, absolutely. I mean, it's great use for authenticating the system that you're working with. I mean, I keep thinking like machine-to-machine identity kind of problems is what I'm thinking about. And
right. In that world, they called it radio frequency fingerprinting. So they call it signal print, radio frequency fingerprinting, specific emitter identification. Anyway, we've seen that most people have been recently using AI to try and boil the ocean to do this. And that takes resources at the edge, and you have to do a lot of work to figure it out. Ours is nothing like that. All we need to do is you say, okay, record, boom, all right, this is good. And now I can just tell you if it's good or not. So
right. Yeah, I definitely want to learn more about it myself. Well, considering, all the intellectual property that your company is generating, right? And the folks that you're working with, how does the aerospace and defense industry think about security, and in particular cybersecurity, differently than other sectors?
Again, I think it goes back to what we were talking about earlier about it matters. You lose the formula to Coke. Okay, yeah, there's some money involved in that. Coke would still deny it even if it came out, and people would still deny it even if it was identical. So that one is kind of at one level of sophistication. I mean, the stuff that aerospace and defense is typically trying to protect is, I won't always say in today's world, it may not be existential, but it's quite important, and there's billions of dollars behind the investments that have been done to create some of that stuff that you're trying to protect. And the adversaries are quite sophisticated as opposed to the average guy trying to break into, steal bitcoins. So I would argue that it's more about the stakes and the adversary that makes it a little more difficult. And because the supply chain and the development and innovation chain is so distributed, it's not all held in one party. The weakest link really comes into play. Even if the U.S. government had a perfect system, it still doesn't matter, because I've got Lockheed and Boeing and even companies as small as myself in this chain at some point, and that still portends some vulnerability that many big companies may not face because they may be able to control their own destiny. The secret to Gillette's process technology for making razors is one of theirs that they be concerned about. And they can probably keep that because they don't share that outside and such. But the DoD, thousands and thousands of players that are involved in pieces of this. So, and the secrets aren't, most of the secrets are numbers. They're data. They're, okay, what's this specification? What is its limit? What is its, et cetera. So they're also very kind of esoteric qualities that, you can't just put in a vault somewhere. What's the mold line on the F-22 from this angle with this frequency of radar?
Yeah.
That's a massively important secret, but nobody in the world cares about it except our adversaries.
Right. Well, I mean, I think I remember we had like nuclear propulsion, security systems, right? Like, how do we, what's the shape of our propeller? Was a huge secret that we needed to protect, right? Just because it helped us with our whisper technologies and whatever it is that we're going to do, so that we can't be detected underwater. And you're right, there are adversaries, right? The people that want that information are our adversaries. I think you put it pretty well. It's the stakes. What are the stakes here, right? And how important are these stakes? It's a completely different from a consumer perspective. Like you were saying, Coca-Cola, and hey, we have a formula that tastes like Coke and it looks like Coke, but is it Coke? Well, Coke has the brand, right? Even if they lost the formula, no lives are going to be lost because of it. No one's going to be inconvenienced because of it, except for shareholders.
Yeah.
As opposed to the defense and aerospace industry, those components is that we're starting to talk about loss of life or loss of capabilities or loss of the American way of life and those kinds of things. We start talking about big picture problems that are multi-generational failures, right? So security is important to the aerospace and defense industry. And I think it's changed a lot too. I remember when I was doing the work, there was no cloud. The FedRAMP didn't exist, right? We built our own data centers. We had our own physical security. We knew who was coming in and out of that space. We knew where our machines were and that we're going to be accessing these data centers. It was a very closed kind of network. Yeah. And today, I imagine I imagine that on our secret networks and our top secret networks, we still have, Microsoft Exchange, and we can still send emails back and forth between people. But I think in the unclass space, right, in the environments, it's harder and harder to get away from like SaaS products. I imagine that this is a trade-off that you're having to make as a CEO, whether you hire engineers to build networks and systems so that you can have your own enclosed loop, and then hiring the right cybersecurity people to kind of secure it. And, you're taking on availability risk and cyber risk if you're doing it yourself.
Yeah.
Right? As opposed to going to Microsoft and using M365 and getting their E5 licenses and getting their Defender and DLP products and everything in space into your environment. The cost difference here is huge. right? I mean, it's a whole lot easier spending $30 per person in your environment than it is to spend hundreds of thousands of dollars for engineers, network engineers, systems engineers, cybersecurity engineers, et cetera.
Well, and the Iranians are a good testament to no matter what, no matter how big the air gap is or how deep underground it is, you can still screw with people's, centrifuges with no connections whatsoever to the internet. So there's always, again, if that's the most sophisticated level, but if that's the standard for the most sophisticated level, then having it inside of walls and air gapped is also not foolproof, right?
No, not at all. I mean, I think that, we were talking about the attenuation of these RF devices and being able to tell which one's doing what. What we forget is that my computer sitting on my desk, it is sending a signal. It is transmitting information, even though it's not meant to transmit information. But if I put like a little counter or a little device here to figure out its RFID, I know that we've had systems that were compromised in the past where they could tell what you were typing, just because of what the electrical signals around your keyboard are.
Right. Also the Bluetooth communication from your, whatever, from your keyboard to the computer. Yeah.
Yeah. And so, I mean, I guess asking from a CISO's point of view, right? And if I was your CISO and you have a CISO, I'm sure, and when you're thinking about this, what advice do you have for other people making these decisions? I mean, because these are somewhat difficult trade-offs. Like you said, the stakes are high.
Right. I will first acknowledge that we have 2 employees, so I have not a CISO, or if I do, then I'm the CISO. God help us. Well, actually, our TTO would be the CISO because he's an expert at this stuff. But I think, probably more from my Pentagon experience as to, kind of threats that they were dealing with, which are probably more relevant than my startup is. So we used to spend gazillions of dollars on cybersecurity, and I had a team, big team that looked at that, and we were investing billions of dollars in that issue, and we knew it was high priority. We knew that every adversary was daily, millions of times a day, trying to penetrate us and our supply chain. But there were 2 things that were kind of interesting. One is most of the significant breaches were always good housekeeping failures. Somebody putting a thumb drive where they're not supposed to, somebody having a password that they were sharing. It was just that kind of crap. And, I got 3 million people that work in the Pentagon. If you work in the Defense Department. Now let's go out to probably 30 million in the supply chain. And I have to make sure that every one of them is behaving perfectly and not screwing up thumb drives and not using password to the right way and not share it, And so you're just like, it was funny because we would get money, and then like the president would come back and say, okay, I want to put $2 billion more into cybersecurity. Well, when you put $2 billion more into the Pentagon, there's not better things that get funded. It's worse things that get funded because the list has already funded all of the stuff that's really good. And so the stuff we thought was crap, if you got more money, you buy the crap. You can't buy anything better than your best stuff that you've already done. And again, you can't beat it. It's not the top echelon of cyber tool that's going to win the battle. It's making sure, it's like a shock, some kind of shock system that if somebody uses a password wrong, you have something in their head that buzzes them and makes them feel uncomfortable, so they stop doing stupid shit. Anyway, it's funny because it's not, again, if I was the CSO of whatever company, I would spend 60% of my time on making sure that it was the blocking and tackling was happening every day and people realized how important it was. And I'm spot testing that because that's much more likely to catch the bad guy than the latest and greatest tool at the top of the stack. Now, I'm not the expert at this. You're obviously much more, but that's just kind of what I saw, in the roles that I sat in when I was trying to fund, the big bucks to spend on this.
This is a great perspective. I mean, this is the challenge I think that CEOs and boards have. And I think that's where the problem comes in, right? There's a problem in the cybersecurity industry, I think, right? As a buyer buying a cybersecurity product. And it's almost exactly what you're saying, is that you're spending this much money and now I give you more budget. And now what am I doing with that extra budget? What is it that changes? It's often not a technology problem, as you rightly pointed out. It's neither technology you're using, meaning, you're in a data center or in your own space, in your own offices, and you could be in a skiff or whatever. There's that problem, right? But then there's the other problem, which the opposite of that would be, hey, how do I use cloud services? But often the problem isn't that you don't have the right technology, meaning that you're not spending the money or you're not spending it in the right places. It's that even when you buy it, does it get rolled out correctly? Just the technology front of it. Does it get rolled out correctly? Do you have the right configuration for your particular systems? But it's really, are you being consistent in the application of it? And I think the second problem is, as you're going through your example, what I started thinking about was we had our own data centers, we had a secret network. You weren't supposed to be able to move data from secret to unclass, right? Just simply, right? Not supposed to move data from these places. But we would have people that would send emails with secret data so that they could move data from a terrestrial system, right, to a ship, right? And they didn't have another path to do it, to keep up with whatever documents that they thought were important. They didn't have a path other than to email their secret documents through to Yahoo so they could get it into a secret environment on a ship. And these are the kinds of problems that, you're trying to avoid, is folks, in their
fail to do their job.
Well, it's not that they're failing to do their job.
They're trying to do their job.
They're trying to do their job. Yeah. And they're trying to do it the best can. They're trying to take advantage of what they've learned in the past and bring it to their next role or whatever. And this is all inside the same military community, but not having the systems in place that allow them to move that information in a safe way, or that they are ignorant of the safe ways of doing it, because there was lots of different safe ways. I mean, it's not a USB key. Don't use a USB key, right? But even access to those systems may be hard. I mean, we had like Radiant Mercury that would allow us to transfer between different classes of networks and that kind of stuff inside the military, right? But it's hard for I think, CEOs and board members to think about, like, are they spending enough? But the real question is, are they doing the right things with that budget? Are they doing the basic blocking tackling? Because I honestly do believe that if most people did the basic blocking and tackling of cyber, we'd all be in a better place, right? Yeah. And it's part of its awareness and part of its understanding your user community, what it is that they need. But it very much is hey, can you do the right things? Do folks know the right ways of doing this operation? Are they willing to tell you that, hey, they don't have a solution for this? Do they know what security means? I think there's some awareness problems as well. But yeah, the stakes can be high, maybe not as high as the DoD military kind of environments, but even small companies that are protecting their intellectual property, you got to be thinking about how to protect it and what to do. And with the advent of, so many cloud services that are available to you now, that you're probably spending a lot of time in your browser, you probably need to figure out, like, do you have the right security in place, right? So,
yeah. But again, I just think it's just like most things in life. The basics are always the first stop, not the last stop. And they probably are the last stop as well as the first stop.
My wife always says to me, common sense is uncommon.
Yeah, exactly.
But it's the basic. But people get bored of the basics. I mean, the people that are doing the work, the cyber engineers and the system engineers, network engineers, they need to feel good about the fact that they're keeping communication lines open, systems are up and running, and that they're secure. But that's not a very sexy part of the world.
Well, yeah, for a technologist, you'd be better off having your behavioral psychologist, hiring that person to be worrying about how do we get 100% compliance on on our blocking and tackling issues, not a technologist, because like I said, it's going to be, like you said, it's going to get bored. But somebody who is into training and getting people to behave and do the things they need to do. And, one of our technologists' traps is they say, well, you can do it. So I want to move on to the next thing that you can't do, as it's very easy to do. Because you can do it and it's easy to do are a lot different. And the ability to get compliance is related probably, one, you have to be able to do it. But two, if it's not easy to do, then people are going to try and figure out easier ways to do it that you may or may not have thought of.
Yeah, human nature, right? You're battling human nature in cyber. And you're right. I think that, I think another thing that you said was absolutely correct as well, is that, it's easy to do something and get it to work, right? It's to do it so that it's also secure. That's a challenge. To do that, it's also going back to probably your procurement and, experiences inside of the military and the DoD, is that one of them is not just the cost of getting into it, but it's also the long-term cost of maintaining it, both from how do you maintain the technology, keep it up to date, but also the manpower required for keeping that system up to date. Right. These are the longer-term costs that should tank systems from being adopted if the cost of maintaining it gets, exorbitant, right? So, but
yeah, I can't remember the acronym, but one of the things that the military is good at, I think it's mil.pdf or something like that, which is, there's a lot more than the material, which is the M, right? Yeah. There's the logistics that go behind it, the training that goes behind it, the sustainment that goes behind it, everything you can think of. And it's not a real for the military unless it satisfies you thought through all of those facilities, everything else.
Right.
That's that type of discipline is typically missed in the technologist world, because they're just worried about the solution, but not the other four letters that have to go with it if you're actually going to make it, sustained inside an organization.
Agreed. You've led teams at McKinsey, the Pentagon, and now MileSpace. What leadership principles has remained constant across these vastly different environments?
Well, that's an interesting question. Leadership is kind of coaching when you're in these roles, and coaching is really adapting to your team as opposed to your team adapting to you. So in the McKinsey environment, you've got excellently motivated, excellently talented people, and basically you're trying to inspire and get out of their way and provide resources to support what they need to do, but you're not having to really tell them how to do anything, right? They have the skill, they have the will, and typically it's just recognizing their performance and making sure it's, going in the right direction. Sometimes it can go off in the wrong direction. What I saw at the Pentagon from a leadership standpoint was the real challenge to getting things done there, because the culture of performance is very high. And it was typically understanding the cross-organizational integration issues that everybody missed. So a good example of this was I was tapped by Gates to do what was called the ISR task force. And we were trying to increase the number of drone orbits that were available to the CENTCOM area of operations for Petraeus and a number of other commanders out there. So a pretty important job. I agreed we needed to do it. And I went out and looked. And so we were out at a facility somewhere, and our goal was to try and get more orbits of these things. And you had to have three things to do an orbit. You had to have an aircraft, you had to have a ground station, and you had to have a pilot. There's more, but those are the three. To get an orbit, you had to have at least those three things in place. But we had tons of planes. We had tons of aircraft, but we were limited on ground stations. So I'm out visiting this facility where it's a training facility for this operation, and there are 6 ground stations, and I walk in on a Thursday afternoon at 3 o'clock, and there's nobody in the room with all these ground stations. They're just empty. And I'd just been 100 yards over, and there were another half dozen ground stations full up running operations, and I'm now here. And this is the short thing, these ground stations. And I said, what are these? And they said, oh, these are our training ground stations. I said, when do you do the training? No, we mostly do it during the day. I said, when do you do operations in Afghanistan? Oh, that would be mostly at night. So why aren't these being used for operations? And I had the vice chief of staff of the department of what the specific service this was. And you could see his eyes just go rolling back in his head. And we, with that one move, created 20% more capacity in the system. Now, was there anybody trying to do the wrong thing? Right? Was there anybody trying to screw up the ability to have these things? Was there any leadership void? Probably not. But there just wasn't somebody who had been asked this question.
Yeah, we're connecting
to maximize something, and then you come out and you see 6 of them not being used, and you're like, why aren't these being used? I said, what do I have to do to cook these up? Oh, we run a fiber about 100 feet over to this, and we'd be up and going. The next 2 days later, they're up and going. I didn't have to do that. That's the thing you have to do in a lot of companies. You can't just recognize it and it gets done. That doesn't happen in a lot of places. The Pentagon, it does. When everything I did at leadership, it was figuring stuff out and explaining and helping people understand why that was the deal. And it usually wasn't that hard because they saw it immediately once they realized this was what they were trying to do. And then mission, execution, boom, it was done. I never had to follow up on execution. So it's kind of, I don't know, I think it's the situational leadership where you take what's going on and you really have to mold yourself into those roles and what's needed for this particular athlete, participant, situation, business opportunity, and trying to be flexible with that. Now, I know there's people who have, done a lot of things, and, you're asking the wrong guy about leadership from somebody at the Pentagon. I would point you to much more capable people in that field that came from that place than me. But, what I've seen is, I think that's the wisest statement. You tailor your leadership to the needs of the team, and you motivate people with what's going to motivate them, which requires you to change, not them. Because you're going to have to figure out what motivates people and how to get them there. That's your job. It's not, well, I keep telling them to do this. Well, if you keep telling them and they're not doing it, it's still you're the screw up. It's not them.
Yeah, thanks for that advice. That's good advice. I think it's very applicable to all levels of leadership, right? I think that we kind of forget that people are there for their own reasons, right? Wherever you are, whether you're at McKinsey or Pentagon or wherever, people have their own reasons for being where they are at that point in time. And you got to figure out what's motivating them. And, and some of it is just like, are we motivated? Is the organization and that person, are we both going in the same direction? Right. Because that's part of it as well. But, given the fact that y'all all are both motivated, then it is about, making sure that you're meeting them where they are and giving them the opportunities that are going to get them to kind of do it on their own, right? Eventually, right? So I think that's a good principle to learn. Finally, when you reflect on your service and career, what accomplishments are you most proud of that people might not know about?
Well, that task force was really important to me. That was really, that meant a lot. Just because it was like, I would say it was some of the best use of my skill set. I already knew a lot about the system when I did logistics. That's probably the area I would say I feel like I had a lot of impact that probably most people would never know about. There was a funny instance once when my boss in that area was retiring, and this was the Undersecretary of Acquisition Technology and Logistics. And the guy who runs the special programs, so the black programs, was saying him off, and he was saying, well, most of you guys I don't know, because every time I'd come and say, I need to talk to the boss, everybody would leave the room. And so I didn't get to know as many of you as I am, but blah, 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 blah. And I was thinking about that. So I get up there and I said the same thing. Anytime I said logistics, everybody would leave. It wasn't because they had to, though. It was because they couldn't care less about what I was working on. So it was a very unsung area of the Pentagon that had, like I said, a third of the people and a third of the money. And we did a bunch of things from, we were moving, I think, 500 million miles of transportation every year. And I figured out a way to deploy it more like the classic logistics players that support Ford and GM and these guys do. And we set up a system to do that. And we were doing, we had lots of places that had multiple levels of inventory in a region. And so, down in Tidewater, for example, you might have 3 different places where the same product was being held. And so I set up regional inventory management systems so we can consolidate that and have better service and less inventory for all of those players. And so it's a bunch of things on that kind of logistics stuff where, nobody really spent any time. Most of the people who were in that position were hacks. They really didn't, they got the job, but they really didn't know much about it or care that much about it. And so that was really fun to do something and really have an impact. And nobody really knew about it, and most people didn't care, because it wasn't what the secretary was concerned about. He had to fight a war.
Well, I think that, what do they say? Logistics wins wars.
Yeah,
right?
exactly.
And that they're not worried about it, they're not thinking about it, is somewhat of a testament of how well it's working. Because if it wasn't working and they weren't eating, they'd be telling you about it. Right?
Yeah, absolutely.
So
absolutely.
It goes back to what we were saying about cyber, which is basic blocking and tackling. You got to have, the right things in the right places and doing the right things every single day consistently.
Right.
And you're probably going to be able to win your war. But if you're all over the place, and it is a different mindset. You were saying, you need a behavioral psychiatrist making sure that they're hiring the right person for their role. Because there are, there's people that are rock stars and there's people that want to just push rocks. Right. And you need the right person in the right time to do those things, but it does take a different mindset. But there is a quote somewhere that says something about logistics, something wins battle.
Yeah, I think Napoleon gets credit for it. Amateurs study strategy, experts study logistics, I think is
that's another good one.
Yeah.
Very good. Well, Brad, I truly enjoyed having you on the show.
Thank you.
Take your time.
My pleasure. Glad to be here. Hope this is helpful to everybody.
It definitely will be. Thanks, Brad.
All right.